All right, let's look at the homework 8, problem number 10. All right, so let's look at this problem. So first we want to find its domain, right? So in order to find its domain, we're going to just, factor out the numerator and the denominator first. So we have f of x is equal to, right? The numerator can be factored out as x minus 5 times quantity x plus 8, and denominator can be factored out as x minus 5 times quantity x minus 7. Right? So you can see that the domain is going to be all real numbers except for 5 or 7. Right? So let's look at that. Actually already, so we got that one. All right? And the intercept is going to be, right? So let's find the intercepts. So we're going to set, so x-intercept would be, we set the whole function equal to 0. So you can see that x equals 5 and negative 8, right? Then y-intercept is going to be, we can just plug in 0 everywhere. So it's going to be y is equal to negative 40 over 35, right? And which is going to be negative 8 over 7, right? So x-intercept is negative 8, 5, and the y-intercept is negative 8 over 7, right? So let's stop. All right, so you have negative 8 and 5, and the y is negative 8 over 7. So C is the right answer, all right? So check that. Oop, actually, I messed that up. Let's see, where did I go wrong? Oh, okay, sorry. X cannot be 5, so yeah. So I have to eliminate that because x is not in the domain. So it's actually just negative 8 and negative 8 over 7, right? Sorry about that. So it's a negative 8 and the y-intercept is negative 8 over 7, right? This should be it, right? We got that. All right, so horizontal asymptotes, right? So easiest way to find a horizontal asymptote is, let's say you have same power on top and bottom. So we look for the leading coefficient on top, which is 1, over leading coefficient on the bottom. So it's going to be y equals 1. So it's going to be one of these. Right, vertical asymptote is going to be, right? So in order to find a vertical asymptote, you need to cancel out the common factor and set the denominator equal to 0. So vertical asymptote is x equals 7, right? So we have x equals 7 up here. So A is the correct one, right? We got that. All right, so let's see, increasing, decreasing behavior. So we're going to have to take the derivative here. All right, so I already canceled the x minus 5 and x minus 5 there. So we can just take the derivative without those factors, right? So using the quotient rule and square the denominator, which is x minus 7 squared. Right, derivative of the top is 1 times the bottom, which is x minus 7, minus top is x plus 8, times the derivative of the bottom is 1. Right? So you can see that x minus x cancel out. You're left with it's negative 7 minus 8, so it's negative 15. Oops, I'm using a wrong color. It's going to be negative 15 over x minus 7 squared, right? Right. This means that, let's see, this derivative is actually always negative, right? So it's as long as it's defined, it's always decreasing, right? So let's find that. So it's going to be decreasing on, let's see, increasing and decreasing on, actually none of these. How come it's not, all right, so I'm going to have to take a chance. All right, so it's decreasing on, I think this is only the closest one. They should really eliminate the 5 too, but I'm gonna just go ahead go with this one. All right, so I think the system is a little bit incorrect. All right, and then we have there's no local extrema. All right, so there's so it's always decreasing, so there's no local extrema. So we have A is the right answer. Check the answer. We got that. All right, and to summarize, so let's say concavity. So we need to take the derivative again. So here, this can be rewritten as negative 15 x minus 7 to the negative 2 power. So if you take the another derivative, you're going to get, let's see, negative 15 times 2, negative 2 would be positive 30. X minus 7, subtract 1 from the power, so it's negative 3. Multiply by derivative inside, which is 1 anyway, so it's going to be 30 over x minus 7 cubed. All right, so we can, let's see, do the number line here. All right, so domain is all real number except for 5, so I'm gonna have to put 5 here, and also 7. All right, then we're gonna look at the sign. So anything less than 5, so I'm gonna try I like 1. All right, so if you put 1, that's negative cubed, so it's going to be negative. All right, and if you look at the f double prime of 6. Right, it's still negative. Right, so if you look at f prime at 8, it's going to be finally positive. So you can see that the original function f is going to be concave down here and also concave down, but it's concave upward after 7. All right, so let's look at that. All right, concave upward after 7. So here, concave downward, negative infinity to 7, and then concave up after that. All right, they really need to eliminate the x equals 5, but I think they forgot to do that. So check the answer. All right, we got that. All right, and there's an inflection point. Let's see, is there an inflection point? All right, so concavity changes at 7, but remember that there's a vertical asymptote there, so there's no inflection point. All right, so there are no inflection points. All right, check the answer. All right, we got that. All right, so we need to find a picture. So let's see, at the x equals 5, it should be undefined. All right, so this is not it. And here, this looks promising. And this one looks promising. And this is not it. So between B and C, right? Then remember that it start out concave downward and a concave upward. Right, so concave upward here, so start out concave downward and concave upward. So this is the only reasonable picture. All right, check the answer. We got that. All right, that's it. I hope that this was clear.